Assalamualaikum everyone. Let's learn about interference of reflected light in air wedge and Newton's ring. For this subtopic, there will be two experiments. Both will apply the same concept of air wedge but different apparatus and different results. To produce an air wedge, we can form it by placing a thin piece of foil or paper at one end between two glass plates. Based on this figure, we can see there are two glass plates and we put a sheet of paper right here to make sure there will be air gap between these two glass plates. Then there will be a light source from above and the result is on this glass plate. You can see there will be a series of dark and bright fringe right here. So syarat nak menghasilkan air wedge is mesti ada air gap in between these two glass plates. The thickness T of air wedge is varies. Why? Because when thickness is changed, the results, which is the bright and dark fringe, will be changed. Let's learn more detail about this air wedge. When incident ray or a monochromatic light incident on the first glass, it will reflect at this point A, produce ray 1 right here. And for this process, during this reflection, since it reflects from denser to less dense medium, from glass into air, so there will be no phase change at this point A. Next, part of the incident ray will refract into this air wedge and then reflect at the second glass to produce ray 2. So when the light reflects from air to the glass, from less dense to denser medium, thus there will be phase change right here. When we look at the distance traveled by ray 1 and also ray 2, we can see that ray 2 travels at extra distance of path difference equal to 2 and t before recombine with ray 1. So kat sini nanti ray 1 and ray 2 akan berlaku interference and you can see from your eyes there will be a series of bright and dark fringe. Since ray 1 has no phase change while ray 2 has a phase change, thus both rays will act as antiphase coherent source. For the constructive interference or bright fringe that you see, you can use the equation 2nt equal to m plus half lambda, while for the destructive interference or dark fringe, 2nt equal to m lambda. For the order number, we always start to calculate the order number from this point. Since the glass plates both are in touch with the other, dia bersentuhan, bertindih kat sini. So this air wedge always start with dark fringe. So we can find the thickness of this air wedge dekat hujung ni kita nak cari. And then for this air wedge, there will be no central bright or central dark. Sebab kita akan tengok start daripada dekat ujung ni, which is always start with dark. So to determine the order number m, first bright is m equal to 0, second bright m equal to 1. Untuk dark pun sama juga, first dark is m equal to 0 and second dark m equal to 1. Example 2.6. An air wedge between two glass plates are illuminated by a monochromatic light of wavelength 589 nanometer. A total of 40 dark fringe are observed. This ayat ni you all cancelkan. What is the thickness T of the foil? So kita nak cari T. A total of 40 dark fringe. Okay, maksudnya kalau ada 40 dark fringe, M will be equal to 39. Sebab first dark fringe, M equal to 0. So 40 dark fringe, M will be equal to 39. To find the thickness, since we refer to the dark fringe, we are going to use this equation 2nt equal to m lambda to n. To determine n ni, refractive index of medium, we always refer to the airway. So the refractive index number of air in between these two glass is 1.0. T thickness equal to m is 39 and times with the wavelength 589 times 10 to the power of negative 9. So we will get the thickness 1.15 times 10 to the power of negative 5 meter. Just now we used two flat glass plates, and in between them there will be air wedge. What if we use a plano convex and also a flat glass surface? If we use that apparatus, we will see a series of dark and bright fringe in shape of circular rings that we call as Newton's ring. So Newton's ring is a phenomenon in which an interference pattern is created by the reflection of light between two surfaces. The first one is a spherical surface and second one is a flat surface. So what we do is we put a plano convex lens on a flat glass surface and it will form a circular shaped air wedge. So the result is we will see a series of concentric rings is seen when illuminated from above monochromatic light. These are called Newton's ring. So ini adalah dia punya contoh apparatus and these are the result that you will see on the screen. Please take note that during lab you will do this Newton's ring experiment and you will use a Newton's ring apparatus to get this kind of Newton's ring on the screen. So what will happen when light enters this plano convex lens and also flat glass surface? The incident light will enter to this glass and reflected at this point to produce ray 2. During this reflection, there will be no phase change because it from denser to less dense medium, so no phase change. Next, part of the light ray will enter this air wedge, ruang udara kat sini, and reflected at this point. So the reflection is from less dense medium from the air into the glass to form ray 1. So kat sini akan ada phase change. There will be phase change. Since ray 2 no phase change, ray 1 has a phase change. Thus they will act as anti-phase coherent source. Both reflected ray 1 and ray 2 will interfere and form Newton's ring. So on the screen you will see a series of circular ring of dark and bright. Let's focus on the order number. Since the center is dark, so it will start with m equal to 0. First dark, m will be equal to 1. Second dark, m will be equal to 2. And third dark, m equal to 3. For bright ring, the first bright ring is m equal to 0. Meanwhile, second bright ring will be m equal to 1. Okay, so dia berbeza dengan air wedge using glass plate tadi. Kalau glass plate tadi dia takkan ada center. Dia cuma ada start from dark sahaja, hujung tu. Okay, for Newton's ring experiment, we have a center. So we need to consider the center as center dark. For the equation, condition for constructive interference or bright fringe that form on the screen, the equation that we can use is 2nt equal to m plus half lambda. For destructive interference or dark fringe, the equation is 2nt equal to m lambda. Meanwhile, for the determination of m, if the center is dark, kat sini kita tengok center dark, m equal to 0. So, untuk first dark, m equal to 1, second dark, m equal to 2. But for bright, first bright, m equal to 0. Second bright, m equal to 1. So, if you have the third bright, m will be equal to 2. There will be a case where the center of the Newton's ring is bright. Macam mana pula center dia boleh bright? Okay. If there is air gap in between of these two plates, thus the center will be bright. So you need to use this equation for constructive interference to nt equal to m lambda. Destructive interference to nt equal to m plus half lambda. To determine m when the center is bright, so center bright, m will be equal to 0. First bright, m equal to 1. Second bright, m equal to 2. For dark, first dark, m equal to 0. Second dark, m equal to 1. Kalau you ada third dark, m will be equal to 2. Okay, let me share a bit for the experiment 3 that you are going to do in the lab. So nanti masa you buat experiment 3, you will see that your center of Newton's ring is bright. When you set up the experiment, you switch on the light, you put on the Newton's ring apparatus, the lens, the color filter, then you will see a series of circular rings on the screen. First, you need to label where is the center. Okay, you can conteng the screen using your pencil. Let's say you use first color filter, which is blue. Label the first bright, second bright, third bright, fourth, fifth, and sixth bright. Okay, label. So this one is for blue contohnya. And then change the color filter into green. This one is for green. Then change to the last color filter, which is yellow. Then you are going to measure the radius of each order number. Transfer all this data into a table that will be given to you. Okay, saya bagi contoh. Okay, and radius, radius square, and also diameter. So for the first bright, n will be equal to 1. What is the radius? Untuk radius, we are going to use scale. Scale dia adalah 1 cm equal to 1 mm. So kalau you ukur kat sini untuk first bright, use your own ruler in centimeter, then you get 4 cm. But when you transfer into this table, apply this scale, so you akan masukkan 4 mm. Why? Because later when you enter the lab, you can take a look at the Newton's ring apparatus. There are scale on it. So scale tu sebenarnya dalam millimeter. Tapi bila kita gunakan lens, dia akan become bigger, but actually the size is in millimeter. Okay, so that's why you need to apply this scale. So completekan all this table, and then from the data you need to plot a graph of r square versus n. And this one is r square. R square, dia punya unit is in millimeter square. Okay, when you have plot the graph, find the gradient and use this equation beta equal to r lambda. Beta is the gradient equal to r. R is a constant value, which is 12.13. So if you use the gradient for blue light, then you will get the wavelength of the blue light. Compare your result with the theoretical value. Please take note that the gradient that you will get is in millimeter square, and the value of r for the Newton's ring apparatus is 12.13 meter dalam meter. Okay, so kena convert dulu gradient ni dalam meter square, baru boleh kira to get the wavelength of the light. This is just the idea of the experiment. So nanti please read the lab manual that I've shared in goals and watch the demonstration video. Okay, let's do the example 2.7. A plano convex lens is placed on a flat piece of glass. So from this statement, we know that this will produce a Newton's ring. When light of wavelength 580 nanometer is incident on it, 48 bright rings are observed. This is M. What is the thickness T of air in between the edge of the lens and the glass block? Let the center of the Newton's ring is bright. So kalau center dia bright, means that there will be a little bit of air gap in between plano convex and also glass surface. And we want to find the thickness T of air in between these two glass. When we talk about bright rings ataupun constructive interference, so we will use this equation 2nt equal to m lambda. Then how to determine the m? So if the center of the Newton's bright, m equal to 0, there's 48 bright rings, m will be equal to 48. So substitute into this equation 2, and medium in between these two glass is air, so n will be equal to 1.0, thickness equal to m is 48 times with the wavelength 580 times 10 to the power of negative 9. So the thickness will be equal to 1.39 times 10 to the power of negative 5 meter.